Hello all, my name is Divya Kadam and I'm from DY Patil College of Engineering, Akurdi, and I'm studying in the branch ENTC. And I have completed the Embedded Systems internship provided by Emertx, and today I'm going to present whatever I learned or whatever project I have made during this internship. So let's get started with the presentation. Sorry. Okay, so the technologies that I have learned during this internship. So, firstly, we have learned C language and Embedded C. The applications that we use to make this project. So, the first and the most important app that we used is an MP Lab. So, this MP Lab is an integrated development environment and it is an expandable, highly configurable software program that incorporates powerful tools to help you discover, configure, develop, debug, and qualify embedded designs for most of our microcontrollers and digital signal controllers. MPLab IXT works seamlessly with the MPLab development ecosystem of the software and tools, many of which are completely free. Another application or another software that we have used is PiximLab. So this is a real-time simulator of development boards with MPLab, and it supports microcontrollers from Pixim, SimAVR, UCSim, etc. So this is in integration with this for programming the microcontrollers boards. So as the purpose of the Pixim lab is to emulate real hardware, it does not have any source code editing support. For code editing and for debugging, we already have our 2MP LabX. So it supports several devices and spare parts that can be connected to the boards for simulation. Such an example, LCDs and push buttons for simple outputs and inputs, and some more complex one like the Ethernet shield for internet connection or the color graphic display with a touch screen. So there are many parts which we can include into our Pixim lab, and another one is microchip offline, which we have used to compile whatever we make. So our project is completely based on a microcontroller. So let us first understand what is a microcontroller. So a microcontroller is an integrated circuit which is small, low cost and self-contained computer designed to handle a specific task in embedded systems. In simple word, a microcontroller is a small computer integrated into a single chip. So now from this sentence we can understand that a complete computer, a big computer, you can just visualize a big computer in a very small chip. So this microcontroller is a something that is referred to embedded controller. Microcontrollers are found in vehicles, robots, office machines, medical devices, mobile radio transceivers, vending machines, and home applications, among other devices. And they are essentially simple miniature personal computers designed to control small features of a larger component without a complex front end operating system. So, the two technologies that we learned were the C programming language and Embedded C. Now, everyone knows about the C programming language, the very basic programming language which most of us programmers begin with. So, it is a general purpose computer programming language which was created in 1970s by Dennis Ritchie, and it remains widely used and influential. Today, also, when anyone is stepping into the world of programming, the very first language that they learn is C language. So, by design, C's features cleanly reflect the capabilities of the targeted CPUs. It has found lasting use in operating systems, device drivers, and protocol stacks, but its use in application software has been decreasing. C is commonly used in computer architectures that range from the largest supercomputers to the smallest microcontrollers and embedded system. C programming language is the one which we learned during our internship, which enabled us to write our source code because which was primarily written in the C programming language. Mostly C programming language is used for the hardware purpose, and a more detailed version of this C we can say is a embedded C. So it is a popular programming language in the software field for developing electronic gadgets. Each processor used in electronic system is associated with embedded software. Embedded C programming plays a key role in specifying like tip, in specifying the specific function by the processor. In day-to-day life, we use many electronic devices like such as a mobile phone, washing machine, digital camera, etc. These all devices working is based on microcontroller and that are programmed by embedded C. So Emertx typically requires a non-standard extension to the C language in order to support the enhanced microprocessor features such as fixed point arithmetic, multiple distinct memory banks, and basic input-output operations. So, the C Standard Committee produced a technical support most recently which was revised in 2008 and then reviewed in 2013, which provides the common standard for all implementation to adhere to. It includes a number of features not available in normal C, such as fixed pole arithmetic, named address spaces, and basic input-output hardware addressing. Embedded C uses most of the syntax and cinematics of the standard C, that is the main function, variable definition, data type declaration, conditional statements. Conditional statements include if statement, then the switch cases, then loops like for loop, while loop, functions, arrays, strings, structures, union, bit operation, macros, etc. So if one has to master embedded C, the path goes through C. One has to first learn the C language, and with the help of the C language they can very easily learn embedded C language. So these are the two languages which we use to write a code in this project. So now what is the actual project? We are making a microwave oven. We all use microwave oven in our home, but have we ever thought about how it works or what is actually inside it? So that is what we have learned or studied in this today's project. So a microwave oven, we everyone know about a microwave oven or a simple microwave, which is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. This includes polar molecules in the food to rotate and produce thermal energy in a process known as dielectric heating. Microwave oven heat foods quickly and efficiently because the excitation is fairly uniform in the outer 25 to 38 mm of an homogeneous high water content food item. So this is the actual our project which we have developed during this internship. In making this project, we have also made use of different components which are associated with a microcontroller, and we have linked them to use them in our project. So now we'll take a look at those. So the next component that we have used is a CLCD. So a CLCD is stands for connected limited device configuration. So it is a liquid crystal display only, like in our microcontroller we have to display our output on a LCD screen, and to present certain things on the screen and to put our things onto the screen we use this CLCD, which gives us a visual feedback. So the next thing that we have used is a matrix keypad. So now if we have to give certain input to a microcontroller, then for sure we need a keypad so that we can select different modes, or if we have to give certain input to a project, then there should be a way to give the input. So the matrix keypad is the way to give the input. So the matrix keypad, it is a Most of the applications of an embedded system requires keypads to take the user inputs, especially in case where the application requires more keys. So with a simple architecture and with easy interfacing procedure, matrix keypad are replacing normal push buttons by offering more inputs to the user with a lesser input output pin. As a human machine interface, keypad plays a major role in vital microprocessor and microcontroller based projects and equipments. Therefore, we have used this matrix keypad into our project, and it's most commonly used input devices, and it has various applications in the areas of digital circuits, telephone communications, calculators, ATMs, and so on. So it consists of push buttons and switches which are arranged in the matrix format of rows and columns, which is very similar to one we can see on our mobile screens or laptop screens. These keypads are available in configuration like 3 by 4 and 4 by 4 based on the application it is implemented for. So the next is timers. So timers play a very important role in embedded system. Their duty, of course, is to maintain timing operations, be it controlling the blink rate of the LEDs or controlling the sampling rate of the ACDs or a simple delay on a source code. A timer is a specialized type of clock which is used to measure time intervals. A timer that counts from 0 upwards for measuring time elapsed is called as a stopwatch. It is a device that counts down from a specific time interval and used to generate a time delay. For example, an hourglass is a timer. We use timers every day. The simplest one that found is on our wrist. A simple clock will time the seconds, minutes, and hours elapsed in a given day, or in case of a 12-hour clock since the last half day. So this timer, they are in simplest term. If we have to talk about a timer, then there are register. So what is the registers? Registers are something which hold data, very small data, or can be say a 1 bit at a time. So timers generally have a resolution of 8 to 16 bits. So as an 8-bit timer is 8-bit wide, is capable of holding value within 0 to 255. But this register has a magical property. Its value increases or decreases automatically as a predefined rate. This predefined rate can be supplied by the user as well, or if not, then it's selected by default by whatever application you're using. This timer clock, its operation does not need any intervention of the CPU. They are very useful as they run asynchronous to the main core. And this is a fancy way of saying that timers are separate circuits on the chip which can run independent of the main program, interacting via the control and count registers and something called timer interrupts. Now, what is an interrupt? Prior to learning about timers, we must know the concept of interrupt because timers mainly interact with the CPU through these interrupts. The concept of an interrupt in reference with the microcontroller is similar in our daily life concepts of interrupts. Suppose we are reading this tutorial and like if we are listening to this presentation and suddenly if a mobile rings, then what we will do, we will stop reading, we will stop listening to this presentation and attend the call, and then we will resume this presentation looking at it. So this is exactly what an interrupt does in an MCU. While the MCU is executing a program, if there is something that needs immediate attention, an interpret is generated by that task and the execution of the circuit program is left at that time and interrupt is handled. So in the example that we saw, a mobile is an interrupt and the presentation going on is the execution of the current program. So in between, if the mobile rings, we are going to run to a mobile leaving the presentation. So this is a very basic example of an interrupt. To understand interrupt, the timers run parallel and independent of the CPU at a specific frequency and interact with the CPU by issuing interrupts. Now let's take a look at a project. So to make this project, we have written source code, and this coding part we have done in our MP Lab So this is how our code looks like. So this is a project microwave oven, and we have three header files over here and five source files which contain our complete code. So now we have used this software for writing our code, compiling our code, and the output we are going to see on the Pixum lab. So now I will first reload it. So now our microwave oven is powering on, and we can see that there are four modes in this oven. So the first mode is the micro mode. So to select the first micro mode, we need to give the input 1. So here when we select input 1, our power for this microcontroller is going to be 900 watt, and now we have to set time. So let us set a very small time so that we save our time and we get to see the actual execution. So for seconds I will keep like 20 seconds. Okay, and for minutes let's just not select minutes because it will take longer. So now in this screen we have two options. We can clear certain value if we think that we have mistaken or we change our mind, and we can use the hash key to enter. So this display screen shows us the time that we have selected, enables us to select the time, and now we can enter the time to actually start processing. So now we can see that our cooler has started and it's processing, and we will have to wait to for this to complete so that we come out of it. And meanwhile there are four options which we can use, which are start, resume if you want to do that, if you want to pause it, or if you want to stop it. So now time is up. We can see our cooler is stopped and a ringing buzzer. So now let's explore another operation. Another operation is grill operation. So let us select the operation 2. Again we have to give time, and to save our time we will give a very less time of again 20 seconds. And now we have selected the seconds part. Now we have to select the minutes part. So as soon as I will input the third number, it will consider it as a minute. So let's just not select any minutes, so save our time and we can actually see the execution of our project. Now I have inputted the time and we'll enter it using the hash key. So again we can see that in this mode as well we have four options. If we want to start, resume, if you want to pause in between, if you have to completely abort it. So we can see that the fan is running, and after the timer gets off it will be off. And see, we can see that it has stopped. The buzzer has ring, which has informed us that the process is done and whatever we are cooking is prepared. Now let's see the third mode, which is the convection mode, and to explore this mode we have to use the third option. So we have to set the temperature, which is in degrees Celsius. So we will select 50 degrees Celsius. Okay, so we have selected 50 degrees Celsius, and then it will preheat for 5 seconds. Okay, so now we have to give time. Again, let's take a small time of 20 seconds, and minutes I have selected 00, and now I'll enter using my hash key. Again we can see in this convection mode as well, a fan is running and the timer is running, and if we want to pause this operation for a time or we want to completely abort it, we can use the rest of the keys to start, pause, stop, or again resume it after we have paused it. So we can see our timer has stopped and we have got our buzzer alert. And now the last option, fourth option, that is the start mode. So by clicking on the fourth key, I'll select the start mode. So the start mode runs for 30 seconds as it is pre-programmed, and after waiting for 30 seconds we can see that our cooler will stop and our buzzer will ring to tell us that it is over. So let's just wait. So that was it. The time is up and we can see that the process has stopped. The buzzer has given us an alert that the process is completed. So this is a project. This is the microwave oven that we have developed during this internship, and during this internship we have learned first the basics. Right from the basics we have learned the C language, then the Mdet language, and then using this two languages we have developed our source code and we have presented the output. So thank you so much. I would like to thank my teacher who was exceptionally good during this internship, who cleared all our doubts and made the session very interactive, and we got a lot to learn from this internship. And thank you.